Good morning. Good morning, everybody. Good early morning, in fact. This is Suraj Singh speaking from Bharat, India on this day, September 10, 2021, Friday. Same talk, quality safety, and title is Civil Field Engineering, Life, Quality and AnnexSL, COVID 19, Safety, Health, Environment, Engineer's Role, Designs, Construction, Methods, Contracts, Organizations, Communication, Coordination. All as usual. And why be behind quality all time? Very important issue for everybody. Again, I saw these important documents which declare something. And declare what? Declare this. Requirement of this. Requirement of quality, requirement of safety, health, environment, and application of ergonomics. Without quality, there is no use. Simple. No use at all. Without safety, we cannot move. Gunavatta means quality. In Hindi, we call it Gunavatta. And for safety, we can say we have to keep ourselves safe from mishappenings, or from incidents, or from accidents. We have to keep safe, and we can say accident means hadsa in Hindi. Hadso se suraksha. Ergonomics is a science which advises us, which tells us how to use in a best possible manner your energies. How to use them. You have energies which is equivalent to Shakti. How to use Shakti, how to use energy. Shakti Upyog. If you do not care for quality, whatever work we do, it's no use. Gunavatta bina sab kaam bekar. Quality required everywhere and in every activity in life and in engineering. गुणवत्ता हर काम में आवश्यक. सुरक्षा बिना सब कर्म बेकार. उत्पादन हो या उद्योग हो या निर्माण, every work, every product requires quality. It may be manufacturing, it may be industrial actions, it may be construction, or whatever. Quality is necessary to be included, to be inculcated, to be inserted into every work. I am specifically expressing this because people say when there is work, it's quality work. Yes, it is quality. It should be quality work. But it doesn't work these days. When people are behind money, everybody runs behind money. Everybody wants to earn. They don't value quality. They just want to run. And I think very, very few people realize meaning of quality, meaning of security. If your work is not secured, if your people, your personnel are not secured, whatever they do, it shall be subject to incidents, accidents. Therefore, quality and you can say safety. When I say safety, it is in short. Safety, it includes health, it includes environment, and of course, it includes application of ergonomics. Everywhere it's required. We cannot run away from that. It's written, you can read. It's kind of science, ergonomics, economics. Actually, you can say it's ergo plus economics. We can analyze ourselves. Ergo can be considered as a unit of energy. How? Economically, we can use our energies. You can say that way. I don't go to conventional meaning which is given in dictionary because that's human, how one thinks. I think that we have to economize using our energies so that energies do not go waste. That's the only point I think is most important. Our energy should not go waste, and we have to understand ourselves what we have to do. There are so many ways to do one work. Somebody prefers one, somebody prefers another one. It depends on mood of a person. But what should be done in a best way so that person is safe and work is safe, that professional has to decide, supervisor has to decide, and for that purpose supervisor must have knowledge about that, how to apply that, how to handle material, how to handle activities if these are not machined one. Because when machine works, we have to control machine, but when human works, we have to see about that human is safe. Machine cannot be changed because it has its own technique, it got its own function that we must realize. Life is important for everybody, because if you are safe, you shall be healthy and you shall work better in a better environment. Environment is also created by good health. If you have good health, you can do better. That is true. If you are not healthy, you can't do, you feel sick, you will feel upset in mind, because health relates to mind also. If you are not healthy, you won't feel comfortable, you will feel uneasy, and you may not be able to concentrate on work. Concentration is very important. I should add concentration in fact to my talk here, because whatever you do, if you concentration on that activity, this means you shall import involvement of quality, involvement of safety, and involvement of technology, or what is required there. And all involvements must then force to use correctly what should be done. Concentration is that. Keep on center, keep focused on center, or keep focused on some objective and move accordingly. So concentration can lead to involvement of safety and involvement of quality. Quality. Without safety and without quality, we cannot move. We always say safety first, and it should be first, it must be first. Because our concern is to do better job, good job, best job. And if people are involved in incidents, you cannot say we have done best job. It's our responsibility to provide security to everybody and make sure that they are secured. They are not going to be subject to incidents or accidents. To our controls, if something happens unknowingly, I can't explain that it's because of either ignorance or doing work carelessly or doing in a way that we should not do. So we should be very much concerned about feeling of pain when somebody involves in incidents or accidents. Those painful times are very bad, and those who are involved in accidents, they understand how one feels. How one feels, confidence is disturbed. One's confidence is disturbed and one feels that to some extent one is isolated. And quality is required, has to be complied with. Whatever requirements we have included, whatever we have defined for our work, that quality has to be complied with in every work. Whatever we say, we have to achieve this level of standard, that has to be done, and we should know in elaborations what we have to do. There is no way that somebody would tell us. We should know. It should be in either written form or in form which has been understood already, or conventional, or we can say it is good industrial practice. Quality is a must. As we said, safety is first. Quality is a must. QM. If you can't do this, you cheat yourself. You are not your friend. You are not your own friend, because you run away from your real responsibility. And a runaway person cannot be called a friend of its own. Most involved professionals in production, in manufacturing, in industrial works, in construction, and wherever you can say development goes on. Professional, most important professional is engineers, Abhiyanta, in Hindi we call it, Abhiyanta. And I have written, अभियंताओं को समझना होगा. This means engineers shall have to understand. Engineers shall have to understand, shall have to realize quality facts, that quality is required. And because civil engineers are mostly involved in development works, and development works means total structure of society, autonomy of society. If we cannot handle anatomy of society, then we cannot do anything. Civil engineers involve that group of people all over this country as well as all over the world, that they can change entire scenario with supports of all other disciplines, mechanical, electrical, IT, agriculture, or whatever else. Of course, it shall be in proportion or in no proportion, that help would be there. Factories help, industries help, because you have to buy materials, products, input by human resources and machines. All those elements are involved in civil engineering, from design to planning to all other activities. We should not name all time, it's waste of time. And systems quality has to be analyzed. System is something, now we can say, kind of structure. It's not structure of building or some kind of structure, another way structure, which we can, this is my system, and you can say that's a circuit of work, how you are going to work. System, HR system, machine system, material system. You can systemize every aspect of development. We can systemize our society, we can systemize our nation, we can systemize our governance, we can systemize our project work. There is no way we cannot do that. Intelligent person does it, because establishing a system takes some time, but it involves, you can say, some efforts, and results of efforts come positively. Of course, there was one God that was named Krishna, and Ram, of course. And what they used to say, we have to understand that. That's very important point of view, not from religion angle, no, from analytical angle. It said, of course it said in Sanskrit, which means something. I'll just speak first so that you can understand what I'm referring to. And that's important for systems or establishments, you can say. And when it's systems, means it also refers to institutions. It also refers to governance. It refers to public. It refers to nation. It refers to whole world. And it says, Yada yada hi dharmasya galanirabhavti bharate. Yada yada hi dharmasya galanirabhavti bharate abhe utthanam adharmasya tadatmanam srijami aham प्रारितरणया साधूनाम विनाशाया च दुष्कर्ताम धर्म संस्थापनार्थाय असंभवमी युगे युगे. These four lines club everything for system. If there is some problem anywhere, it's naming Bharat. I'm not talking of Bharat, it's for whole world. When there is a problem on this earth, people are not happy to work. People got to a level that they want to do bad acts. I'm not happy with that. It's my duty, when God says, God's duty, to check its own world. And I don't tolerate bad people for long, and I have to set them right. I come as human being onto this planet for treating them. I mean to say, because they are sick patients, for curing them, to treating them. And they cannot be cured, they cannot come back to their state required, then I destroy them. And I try, after destroying them, I try to help those who are good people, who are working people, who are professionals, and who are all others who are good for this earth, whom I can rely upon, because I have given them work, and that work must be done. Their job is to do what I have given. Everybody has responsibility, everybody has some focus, destination, and that's for me, not for you. Because you have to come back to my office one day. You are not there forever. I have given you some task, you do that task. If you can't do that task, okay, fine. I'll call you back, I'll kill you, and I'll re-establish my all working systems on earth, which I call systems, we call institutions, we call establishments, whatsoever. That's my number one. I'll re-establish, and that says I'll re-establish dharma. It doesn't mean that it is religion. Every work is dharma. Every work is religion. Work is worship. Worship you can call it, or worship you can call it. It is same thing. When you work, it is prayer. When you don't work, it's not prayer. When you say, no, I want to do only prayer in temple or mosque, it's different. That's different kind of one. That's direct relation. But when you work on earth, you are involved in whatever activity from top to bottom. You work indirectly for God, because you have done, or you are going to do for earth. This is different kind of prayer. That you want to help God. What is your purpose? Is that I came to earth only for that. Not to say that it's my society. Of course, it is relative society, not a permanent society. We all live in a temporary society during travel, because we just establish families, we establish this neighborhood, we start keeping or making relations which are only relative. These relations always break at one point, and we have to leave. So this is different kind of inducement I give you, so that you can understand what we should do, thinking that you have been given some task by that mighty, that Almighty. It's very important. So when I say designs of structure, this means design of systems also, design of institutions, design of how you want to work, how you want to do that. There are people in the world who once come in power, they once come to power, they think it's their absolute power, and that's where they do errors. Yes, you have to decide for good for everyone, and this means you have to decide like you have got some command from that power. That's okay. So we can say design of structures and others must be made decisive, safe, qualitative, and must be reliable for prosecution. So whatever we do, we should do for best of society, best of world, and best of this nature, best of planet. But are we doing that? That's question one. Are we doing something that's good for everyone? No, we are not doing. And latest proof is COVID-19 induction. It has been inducted by God. When people just keep on contemplating from where did it come, from where that happened, that has nothing to do with this. Means from where did it come? Something comes from somewhere. You cannot blame someone for this, because we are human beings. We have a habit of blaming others and thinking that we are right, they are wrong. That won't work. Everybody is right, everybody is wrong. It depends upon your conclusion, depends upon your style of thinking, and you have a habit of blaming others rather than solving problems. Blaming got no result, because there are people who are good, there are people who are bad. This happens all over the world. Some people are positive, some people are negative, some people are multiplying, some people like that. You can say some people thrive, some people don't care, some people run behind money, some people run behind knowledge, some people think that they should have names, some people should have enough money, more and more and more. And some people are neutral, so we don't want anything, we just want to live with peace. It depends. So what I'm saying is, I have not gone beyond my certain horizon. My horizon is that when we work, we should consider both issues, quality, safety, both quality and safety, whether we work in designs, we work in construction, or we work somewhere else in manufacturing or industry, elsewhere in operation, or in other parts of this world, other parts of this nation. We work in offices, administrators, wherever. We should have kept in mind that, we should keep in mind that We have to be safe, everybody has to be safe. And solutions are always there. If you have problems, there are solutions. We should understand this point. Solutions don't come directly by fax or by email from skies. The skies provide solutions to our minds, and our minds are, you can say, receivers, or you can say hard disks. These solutions that come from skies, that come through, we say www now, you can say universe, or you can say www, means it comes through system, natural system. We got information from there, and that information received by everyone. Somebody utilizes that, and that information comes from skies, you can say sky, or wherever that information is stored, that can be called server. We say server is an office, server there, computer server. So that is server there. That server location is unknown, but it is there. We get information from there. So when we do something, whatever we do, we may do manufacturing process, we do construction work, or we do whatever maintenance, or whatever new construction we want to do, whatever we want to do, green, you can say it may be green project, it may be brown project, or it may be new project, or it may be project that has to be extended or modified. In both cases, you can say some policy is required, some chart out is required, how to move further, that's considered charting out. And that charting out at every level, at gross level, at key level, at execution level, at activity level, some we can say sequence is required. Subsequence that we are going to use, we are going to spend money on these resources, and these resources and these technologies that we know properly, these resources should be used. We cannot waste resources, and we cannot, you can say, dilute technology as well. Both points are creative one. Materials are not produced, these are natural one. There is no material which has not got any natural relation with its own existence. We extract materials, we use materials that are available on Earth's surface or which are available below. We use them. Even for food we use them. We use soil, we use sun rays, we use water, we use fertilizer, and we use seeds, etc., etc. And then we can get crop. So there is a system for that. You need these resources, these are available, and then you can grow crops. Same way, we have to understand every procedure in every sector. It's not only that this sector or that sector, in every sector. Of course, it takes time, it's profession, it's engineering, it's, you can say, commerce, it's business, but main is technology, operation, how we can use that technology which we have developed. These points must be treated properly. Method statements, we can call them, for construction purpose, for, we can say, every activity. And these method statements are not by title but for actions. Title can be method statement, that can be, you can say, kind of plan, we may call it plan also. You can say it's execution statement, you can say it is development statement. It's up to you what you want to say. That title is not important, but its contents are important. Somebody call method, somebody call procedure, somebody may call in some language something else. It doesn't make a difference as far as criteria is covered. What we are going to do, what shall we do to achieve this object, means our focus should be on object, should be on target. This is our object, this we have to carry out, and that is what his method is. And then you have to involve all resources, machine resource, or we can call equipment resource depending on requirements. We can call human resource, depending on requirements of work, which classes of human resources do we need, and also machines. Machines are very important. Heavy machines, light machines, tools, these are all important. Then which reference do we need? Which documents we need? Or can say designs we need? And which materials do we need? Which materials are going to be installed? Which materials are going to be included on this? Those are, and then you may say how we are going to. And of course, safety is a part of that. Safety should be clearly defined. What level of safety we have to adopt on this, and what about quality applications, quality controls, quality criteria, you can say realization on those activities. Those are very important factors we have to consider on that. And of course, it's not that you just write something. You have to write what you are going to do. That's important. Writing is not important. What you are going to do, that's important. Everybody has different approach, and it should be. As far as you improve your work, if you want to change some method, you can change it if it works better. Nothing wrong with that. And that should be sequenced. We cannot write something at random. Means you have to write something that's going to instruct others, that's going to direct others. You have to do at this time, you have to do at this time. This is a ratio proportion, this is procedure. And if you think that it's better to define more and more, you can define more and more. There is no problem if that activity is specific one. If some work is very specific, that maybe it has not been worked out in past, or it may cause some problems to workers if we don't define that. Then we have to give explanations, we have to elaborate everything, and that's very important point. So I think that's not a problem. We can write professional methods that way, and then we can talk of sequences, what about output, what timings. So this is, you can say, a necessary requirement for implementation of activity, for carrying out works in a professional way, not in a haphazard way. Or you can say where time is also calculated, that is kept into our view consideration. And as cost also is affected, because if we can save time, we can give quality. Cost, because cost is also impacted, it can be saved, or it can remain at par. You can say escalation can be avoided, and risks which are very, very important, can be resolved if we have every plan with us. And engineers are supposed to do that, because engineer means intelligent person, brilliant person, a person who calculates everything. Calculation doesn't mathematical calculation. Calculation means improvement of your proposed activities. How can you work it? You have to calculate time factor, you have to calculate resources, output of resources, input of resources, and you can calculate technology involvement, which one is best, which way we have to work, how people feel better in control if they work in this method or in that method, option 1, option 2, option 3. Because it is work, we can have different options. We can understand element of workforce and element quantity of material, what material, and of course use of machines, and what is best way of doing that work. And if we find some problem there, this means we did not know before, that can be called unknown risk. That should be handled properly, because we have calculated, we have considered all possible problems or involvements. So we can handle risks also. Risk is not something threatening. You can say, do not think that risk is threatening. Risk is just a question mark in itself. Risk knows what it is, but we do not know how can it impact. That's the only difference. Then comes the question of reliability. We defined many times. But more than reliability, there should be RAM, reliability and accessibility, or you can say availability, or you can say maintainability. So reliability can include all those. It's not simply reliability alone. That we consider safety, we consider, you can say serviceability, or we consider durability. As I said, all other necessary resources. So we can say these must be available. Availability must be made sure. Accessibility must be made sure. Accountability must be made sure. And then you can say, of course, maintenance point should be kept in mind, because sometimes we are trapped in maintenance. When you buy something, it's okay, fine, this cost is okay, but after buying, when you maintain that item, it costs a lot. That point should also be kept in view. So reliability can be extended whatever way. I cannot say whatever I am saying or whatever your course says, that's only answer. No, that answer has also been designed by someone, has been, you can say, used by someone, like safety involvement, successful serviceability involvement, durability involvement. And when I said all these, RAM, they call it RAM, and that means reliability, accessibility, or you can say availability, and of course accountability I am adding, it's not given there. You also can say maintenance, maintainability. Just like we say construction ability for construction purpose, or we say buildability for building purpose. Same way we can say maintainability for maintenance purpose, because maintenance is also very significant activity, continuous activity, and ultimately whatever we do, we have to start from something, and that something is called analysis. Analysis is a job that is very, very important, and particularly in world of construction, in world of manufacturing, and everywhere industrialized actions. Analysis is a professional, or you can say it's a core requirement. It applies everywhere, even in non-professional world like our society or other sections, other areas of work, which cannot come directly under ambit of preview or pursuit of, you can say, engineering or profession. Analysis conducted there also. That is different kind of analysis, understanding analysis. It's not mathematical analysis or engineering analysis. That is analysis of understanding. How do you understand something? How do you understand society? How do you understand economy? How do you understand where should we go? That implies that you must have some knowledge regarding that. Everybody has knowledge about society. So that is different kind of analysis. But what I am talking is technical analysis, professional analysis, which is considered major tool in engineering profession. It goes to medical also, but that's different kind of, that depends on x-rays, it depends on medical testing. What I am saying is, when there is nothing available, when we have not started anything, we do not know what we'll do, what should be the final picture. That stage analysis is intelligent analysis, intellectualism. That is brilliance analysis. That's very important point that I'm referring to, and we should not ignore that, because in fact engineer means at one time engineer has nothing, no material, no machines, or you can say no worker, no technology. But engineer is given a task, engineer is given a project, you develop it, you do whatever you want to do. And that's really a critical stage, that you have nothing with you, but you are going to do something, you are going to do a project about which you know nothing. And that stage, you can say, a hypothetical is speculative in imaginary stage, but supported by engineering. Again, don't forget that. We have engineering systems, engineering subjects, engineering considerations. But of course, these are relative to certain standards, and we follow them for conducting analysis. And that analysis is really interesting one if you can do that. When you start our theories, we say, let us assume this, let us assume that. We read all this in applied mechanics, in other physics, chemistry, also in engineering subjects. We always start, okay, let us assume this symbol for this, assume this power for this, assume this. We all do that. And that's the basics, you can say, consideration of analysis, because you have to assume something, and you read from assumption to reality. It's a journey from assumption to physical reality. I'm not saying design reality, physical reality. To do what you assumed, to prove that it can be done, and after doing that, what I assumed was right. And if you think that it cannot be done, then you have to make changes in that analysis. So when I say analysis, you should weigh it. I know everybody knows analysis, every engineer understands analysis, but knowing and understanding is different, but conducting is more important. Can you conduct that? That's the point we have to ask. It's very difficult, but if you are really a person of knowledge, it may not be difficult for you if you have got experience, if you have got potential to contemplate and to know that this can be done this way. One solution, first solution, second solution, third solution. You can reach many solutions. That's analysis, and which is, you can say, which leads to synthesis. But analysis depends on power of thinking, as I say. When I say power of thinking, and thinking means work of mind, and that thinking based on information. Either it may be assumed information or it may be real information. That thinking works for that. And that's wonderful, that you have to think when you have nothing. Thinking based on nothing is very important. Thinking based on assumed availability of things. Thinking is based on assumed availability of things. These things are not available, still we assume that. And that's called brilliance. Use of mind, imagining something. When you design something, okay, so now softwares are there, but basic design is not by software, it's by yourself, by myself. We have to design something, and that's called, no, nothing is with you, but you are going to design based on information you have from whatever codes or whatever source, and also your own brilliance, your own capacity to work. Are you able to work for this thinking work for number of hours a day? Or you say, no, I am going to get stressed. No engineer can be stressed by thinking. This is my guarantee. No engineer can be defeated by thinking. Engineer has to think. This is religion of an engineer to think. If somebody asks me what's the religion of the engineer, I would just say thinking. Because engineering cannot move without thinking. It cannot work without thinking. When you think something, you can engineer it. You can say, okay, I contemplated this, I got this idea, and now I'm going to transform this idea into physical world. And that should be used. It's not simply transfer. I transferred to physical world, I did it, but it's not going to be used. So there is no meaning of analysis then. Your analysis was defective. You should do it thinking that it shall be used. And whatever objective, whatever article, whatever delivery we do, and that's going to be used in life, that can be said professionalism. We do something for life. And that's also, you can say, combined with contemplation. Everything can give you something, and you have to accept that and think on that again. So there are so many thinking stages in every activity. You can start even by irrelevant thinking, but it shall take you to relevant thinking, because you understand when you think something, how many percent it goes to limit it. Or are you master of that? If you are master of that, then thinking shall be easy for you. Maybe you don't think again and again because you have already that information, you have already got that information in forms of product. So we have to be little careful about this, that we should not say already products are there, we have to think to improve those products. Already contemporary word is there and we have to use that word. So, and all these combinations, as I said, thinking, analysis, synthesis, production, applications, all these can be combined together. And this combination, if we get some answer is to respond to this, response to these, we can say these parameters of applications, thinking, synthesis, and whatever else can be called applications. Engineering applications and whole statement of promotion, of design, of application, of maintenance, whatever it is, in industries or in construction, this can be equated to engineering. Based on many safety parts, criteria, many considerations of, you can say, quality, and all other requirements, all other definitions, elaborations that are done. If all those are, you can say, positive, we use them correctly, we can say there is no quality non-compliance, non-conformance product, and it's conforming product, conforming to what we thought of. And you can say if there is non-conformance, which means that there has been ignorance, there has been carelessness, these people did not take it seriously, and then who is to blame? Non-conformance means professional or engineer is either careless, has been ignorant, has been incompetent, and therefore is one who is redundant, who is not required. So we have to understand these points very well. Requirements must be made. I'm just trying to explain as much as possible. Requirements, quality requirements checks being a must, and you can say missing which we have to blame ourselves because we are engineers for quality achievement failure. Engineering means quality application and continuous improvement of quality. Continuous improvement of quality, that's called engineering. And there is no way that exists not to comply with defined or specified quality levels, because definition of quality is a must. And that definition requires to be achieved, or else work leads to status of being unsuccessful and to be reperformed. Quality for me is very important. It should be important for you as well. They talk of skills. I think there is no skill more than if you achieve quality. Safety, of course, you are bound to accept, but quality sometimes people ignore. And this is, I can say, if you ignore, I would say you are not engineer, you are not supervisor, you are not leader. If you ignore quality, we cannot ignore, because we can't do anything without quality. Maybe we formally define that, or we formally don't define that. It is included somewhere. Maybe we could not top up properly, we could not fill in properly, but quality also exists there, which we can call substandard, or we can call whatever. So my dear, in last time, my habit has become that I start with speaking about what's happening in the world. I think it's my habit. When we talk something improvised way, I don't refer to books or some technical notes. I start speaking as such every time we discuss. That's what important is, because your mind should work on its own. It should not all time refer to those documents until you can't do without that. And because I have been sharing this medium, this forum of, of Facebook, which by chance allows on videos, live videos, document share or screen share. That is better. In fact, we can refer, because my face is not important for you. Work is important. Information is important. What shall you do in my face? Nothing. This you can say benefit of this website, Facebook portal, we can take. Of course, I am speaking, you are listening to my voice. What's the matter if you can't see my face? You can see documents. That's important. So when I said in last talk, I put a concentration on inspections and audits. Also before that, we considered that, what was that about? Safe work it was, I remember. It was about safe work. There are some sketches which I have not completed so far, except some you can say, if I am sure it was sketch to general sketches 37 it is, yes. Safety related sketches. What is the safety related sketches? Let me see what it says. Yes, it was that one. Safety related sketches. And other one is also saying same thing, but what's that? Let me see what's the difference. Oh, this is individual sketch, so this is very close now. No problem. Okay. Now, these sketches, of course, we will discuss in details everyone, but now I am going to move to inspections and audit, which we discussed last time at length something, but that was not over. And I think we were referring to some list. So we can say now in that list there was some, I think there was some list, big list, that list was administration, etc. It was. Yes, that was this one. Before we review this also, I think we missed one. Let us see what is this. HSC audit team checklist. Again I am doing this because we have to refresh. It says that HSC audit team checklist means, what is checklist? Let us be clear about that. Maybe it is obsolete one now, but checklist is checklist. And is HSC audit team checklist, that's attached one. Area safety inspection checklist, safety inspection action plan, format and monitoring and surveillance program. So what we say here is HSC or SHC audit team checklist. What actually they should check in general, means not specific. It's equipment installed in accordance with approved area classification as item number 1. Equipment installed in accordance with approved area classification, that is a part of checklist. Means we have to be very specific about it, that has it been installed in accordance of requirement or classification. Then flare fence installed, handrails and toe boards installed. You know what is handrail, what is toe board. Handrails and toe board installed. Adequate and unobstructed easels. See, at various locations is trying to tell. Adequate and unobstructed easels. Easels, very narrow gap when on both sides people sit in chairs that walk small width of total length people can use for walking. It is available everywhere. and you can say that's called ASL. And regarding handrails and toe boards, which are always installed on railings, handrail and its toe board, so that your leg should be free, shouldn't not go out, feet should not go out. And we can say adequate and obstructed ASLs. Edges should be quite wide, so that you can walk on steps or otherwise comfortably and freely without being obstructed by any other object. Walkways and headrooms available. Walkway, we say, with whatever we have, of course length is there, that should be good enough for you. And that walkway or paving of walkway and headroom in height, if it is a covered one, headroom is that your head should not touch anything, it should be free, so that we can say when you're standing on floor on a surface, your head should be free from hitting something. Headroom available, so you can say adequate and unobstructed ASLs, walkways and headroom available, that's to be checked. Minimum of 2 stairways and or ladders for all operating platforms. Platforms means temporary platforms which are used for permanent works, and these platforms can be on ground level, these platforms can be underground level, and these platforms can be on higher levels. We have to access to them, and for that we can require stairways, temporary stairways made of ply or made of timber or made of steel, made of whatever material, or we hire that stairways. Minimum of 2 stairways and ladders. Either ladders, though ladders not preferred for complex works, for access of human you can say, so we should say rather giving more weight to stairways than to ladders for all operating platforms. Ladders can also be used in light way or not in that capacity. You can say pressure relief devices installed. Pressure relief devices installed. That's a question mark that has to be checked in. Means if there is pressure work, there is pressure system, something somewhere, maybe gas pressure, maybe liquid pressure, water pressure, and that pressure relief device is installed or not installed. Because if pressure is more than design, it can burst pipeline, it can cause whatever else we can consider harm. So that pressure, overpressure you may say, that pressure relief should be conducted automatically. Pressure relief device is installed, that is also point of checking checklist. Then we can say atmospheric vents installed sufficiently high to avoid injury to personnel from hot or toxic releases. It's very important point from safety issues, because on sewer lines you can say there may be vents sometimes, you might have seen. There may be vent in your homes also, on roof if you go and see some pipe projects from roof surface to some height of 1 meter or more, so that there is smell in that from sewer, that's called vent pipe. There can be offensive smell, and that smell should not go to your nose. It should remain above level of nose, so that of course it is a smell, it's lighter, much lighter than air, so air will take care of that. Same way on major plants, oil plants, construction, facilities construction, you will find so many such, you can say, vents requirement to be installed, and you have to inspect them. It can be vent from many units where gases can be released. It can be vent from high level of flare which sets fire on gas. Likewise, you can say On water tanks, underground water tanks, you can find some vents are there, though it's not offensive because it is water. You can say on sewer in sewer treatment plants or sewer line, such vents are installed at many locations, and some are installed on water lines also, water pipes also, but that is not for that purpose. It's just to avoid air lock. So we can say atmospheric vents installed sufficiently high to avoid injury to personnel from hot or toxic releases. Hot or toxic release means gases. Whatever gas is released, hydrogen sulfide or someone else, carbon dioxide, carbon monoxide, or whatever gases else, you can say that cause injury to your body, to your mind, and because of its hot and toxic nature. And we can say then next one is atmospheric vents properly positioned with respect to prevailing wind. That point we have to consider that atmospheric vents properly positioned or not properly positioned with respect to prevailing wind. Atmospheric vents properly positioned with respect to prevailing wind, and if these are not positioned properly, then we have to check it, because wind changes direction of flow of such vents releases. Then very important point is fireproofing installed. Fireproofing, though it is fire resistant, but usually in conventional way we write fireproof, just like for seismic activity write earthquake proof, though there is nothing as such, but its habit we have adopted, but it has same meaning as resistant. It's fire resistant, it's seismic resistant. Resistant is more important than elsewhere. Fireproofing is really a kind of very high profile activity, a kind of very high profile sub-disciplines, or you can say disciplines also, because some people have got degrees in fire engineering. So fireproofing installed, that is a question mark, big question mark. Fireproofing installed, and we have to be very clear about that. How does it work? How does it not work? I have to just take some minutes from you for reading this. I just see what status of rain, and just 1 minute please. I'll come back, and after that I'll go after 5 minutes later on. Let me see status of rain, because my light's not available yet. Electric supply has been cut off for 3 hours. It's not come back yet. No rain yet, but no light. So I'll take 15 minutes to speak. I'll talk for some time and don't go to roof. Let me see. Let's continue our talk. What you do is compulsion sometime. You can't avoid that. So as I said, we have to be little intelligent in this way. Fireproofing. Now, fireproofing is very wide scope. It is inbuilt or it is provided separately. Fireproofing in structures or fireproofing exposed to use. When we say fireproofing or fire resistance, in structure itself, and what is the structure? The structure is RCC structure. The structure is structural steel. The structure is your block walling, though it's not a structure in fact, but let us consider because it's inbuilt with structural work. So brick work or block work, these are all fire related. But important point is we cannot provide resistance of fire to every material equally. Fire resistance means resistance of fire for half an hour, 30 minutes, 60 minutes, 90 minutes, to 120 minutes. Generally, these are limited. We cannot say this fire resistance has 10 hours. No, we cannot say that. Because we don't have that material developed which won't crumble in 3 hours, 4 hours. Temperature rises to 800 degrees, sometimes we see more than that when fireworks, fire is broken out. And I think there's no major material which can tolerate such temperatures. Even refractory metals cannot do that. Refractory metals cannot do that. That's though this can't be used in buildings or structures, but we can say clay, for example, light as I think. Let me see how long it works. Clay, for example, we can say it may not work that level. Clay is considered refractory material, and refractory material means it can be fractured only at high temperature. We have concrete, we have reinforcement steel in that, and both have different temperatures. Same way we have structural steel, that's also steel material, hot roll, cold roll. There's different fire rating for that. So fire rating is different for different components, different materials. Fire rating in buildings, fire rating in exposed structures, fire rating for flyovers. All are different because flyovers are not subject to fire as such, There's a less chance of fire on flyovers, on roads. Major chances are on structures, buildings. This can be, you can say, exposed to fire. And that point we have to consider rightly. Fire point. Let me see. Just a minute, please. I'm sorry I'm disturbing you all time. There's no other way. Let me see if my inverter is also working or not. Not working. I have to go outside and put it back. Sorry, I came back. We'll go again. I'm disturbing all time. Sorry to say that. I was talking of fire. Fire has different elements, and we have to accept that fact. As civil engineers, I have no objection to accept that because that's part of life. If we deny that fact, we speak against the engineering. So fire resistance that audit team has to work, it can simply relate to those equipment which are exposed. For example, fire extinguishers, dry powder, carbon dioxide or water filling, or you can say it can inspect fire resistant, fire lines, fireproof line we call it, fire line, fire extinguishing lines, fire suppression line, firefighting they call it, firefighting ring circuit, ring main unit we call it. On major projects, we construct certain ring system around that project, internal area or external area, so that every part of project is controlled by that ring main, and is named fire ring main unit, RMU, ring main unit, which is used only for purpose of fire. There are pressure equipments, stacks, which can be connected to firefighting pumps, which are brought by fire tenders, and this water is pressurized one. It remains within line forever, dedicatedly 24 hours is 7, and this fire ring main can be used. Now this fire ring main should remain functional. It is requirement all time. We cannot use this water for some other purpose. Yes, for water for some other purposes can be used for fire fighting. That's different. We say there is below some building or some structure somewhere else, we have got some underground reservoir, and general purpose of that reservoir is to handle fire fighting. Of course, it is meant for other purposes too, but because this can't be pressure one, water in reservoir, in basement reservoir or some other reservoir cannot be pressure one. It cannot remain pressurized. Only ring main unit can be pressurized. So we have to understand difference also. It may be fire tank, you may call it is below foundation, we consider this fire, and we consider another tank for, or we don't consider another tank for any other purpose, because we say our line is pressure line. We pressure from ground, and with that pressure pump we supply water to tanks, roof tanks, or all levels of that structure, that building, we supply pressure water. In that case, generally you might have seen some tanks kept on ground itself. When the ground floor is used for parking or no for parking, means these tanks can be kept there, and pump is also installed there, so that water is pumped. And that goes with quite delivery discharge of water. There's no question of gravity in that case, that's gravity flow. But when we install water pumps on roof of structures or buildings, then water has to be pumped to roof, and when these are filled, we have to stop pumping. And when we stop pumping means water flows down due to gravity. Higher flow get little advantage of that pressure force, or you can say potential energy of that tank, water that goes to, and lower floor gets more pressure. And if we say we make some arrangements of pumping also there, so it's same. And we also understand means how fireproofing works. It's only for water, I'm telling you. When we have structural steel framing, we have structural steel buildings, in which steel is a component. Of course, it's primed one. There's a primer on steel. There may be some painting, some epoxy paint or some other paint, which can also be used for purpose of some waterproofing, as well as there can be some paint which can resist high temperatures. We can use those paints on them, on those members. And if that is not feasible, then we have to find another solution. If those members can be encased in concrete, that is another another provision that encase those in concrete or jacket them if encasing is very expensive. Likewise, we can say we can find a number of solutions for providing temperature resistance to those structures. If you consider concrete building, concrete means RCC, which is a very important material. RCC, of course, to some extent is fire resistant, provided it has got good coatings on this. Steel is embedded in that. When fire breaks up, it starts heating surfaces of those members. This may be column external surface or column side surface. It may be beam sides or beam bottom, or it may be, you can say, suspended slab surfaces. These surfaces are exposed to fire impact, fire heat. First, wherever this fire can touch these surfaces, temperature of that surface rises and it moves inside. It travels very slowly inside. First it crosses concrete cover, which we call concrete space. Means steel is always embedded a little distance from that surface. That is called cover. First we have to handle that cover. If we have enough cover that can resist half an hour or 60 minutes, or it has also some coating on this, whatever kind of coating, that fire can be hampered, or we have something in that, we have some admixture in that can also help. So we can say that cover, if we provide, we can increase that cover as well for allowing heat to stay there, material to stay there together, materials to resist heat, and it should not distress. But there is a limit for that. What happens, external surface in contact with fire, these are impacted, and internal surfaces do not impact directly. So we can say in engineering sense that exactly there is no dimension of that, but internal portion is still safe, while external cover portion, or even if fire effect moves inside, you can say section which we provide, that is for column or for beam or even for slab, these sections are reduced to some extent. Means section that provided strength to concrete to stay, those sections are reduced maybe by 10%, maybe by 15%, depending on time and potential of fire. That type of fire means that structure is subject to part strength, maybe 80% strength, maybe 50% strength. It depends. Means it has to stay there for some time until we have arrangements to suppress fire or extinguish fire. Once fire is extinguished, then we have to apply retrofitting of that structure. But first is structural existence, structural safety, structural state, and that is very important part. We say we can use better concrete. Of course we can use better concrete. We can also use more thickness of cover, but there is also a limit to that. You cannot unduly use cover thickness. So cover, if you thicken it, if you increase its thickness, there are two benefits. One benefit is that it penetration is a question here. Chloride penetration, water penetration, moisture penetration. More thickness means it takes more time to cross this cover. Similarly, it takes more time to cross heat in this cover. So we can to some extent increase or enhance, you can say, fire resisting time, fire break time. Maybe it can be increased from 30 minutes to 1 hour. It can be increased to 1.5 hours, and by application of some paint on that, we can further increase to 2 hours likewise. But I don't think more than that it shall work. And we should not forget that it's not only structure we're talking of, there are other elements also, the components also, like doors and windows, other units. Of course, they shall damage, you can't avoid that. But first requirement is the structure should remain in state, should remain safe. It may be concrete, and we can retrofit it. If you think there's some distress in this, it shall affect fire resistance, it shall affect, you can say, some other resistance, thermal resistance, or you can say whatever else. Distress means we have to conduct that study. Of course, it is safety study, it is engineering study, and we have to provide some means how to reinstate its original state, how to bring back to original state. So there where we can say fireproofing installation is a must. We cannot depend only on fire extinguishers because that is very, very small. It cannot help structure. It can just help, okay, you want to come out of that room in emergency, just you can do that. More than that doesn't work. And of course we can provide more strength to our fire fighting delivery system of water. We can say we can have bigger size tank, or we can have some other arrangements. Lift also is very important factor because lift is stopped during fire and it's difficult to take out people. First priority is that our people should be rescued in safe structure, and after their rescue, still structures should remain intact, so that we can take care of structure. And we have to make sure that there is access to terrace, there is access to various floors, good access. Not necessarily that means we should have access to all floors. If firefighters want to use those accesses, they should be allowed. It should be there. If it's there, they will work on that. Means there are so many points that we can consider for this fire resistance in structural steel, in concrete, and in other buildings. You see bricks and block work. Block work can do something for some time, and bricks can also do, but it depends on quality of bricks. We don't have very good quality of bricks which come from kilns, and we don't have very good blocks also that we use, because in structural concrete we use M30 and M40, but in concrete construction, in construction blocks, construction masonry blocks or masonry units, we don't use that level of concrete. These points must be considered. And we can't depend on plastering or rendering as well, because we may say that this also helps, but I don't think it will help, because this is not that strong material. So only consideration should be limited to structures. Best structure with best coating we have to produce. Plaster doesn't help that much. I don't have that confidence in that, but something else would do. Coatings are better. So we can say that, okay, that's fire, we are talked of. Now we should go somewhere else to talk of, and that is, buildings on plants particularly. And I'm talking fireproofing, means it is on plant, on processing plant, where there's always danger of fire because of many reasons. Fires break out there, and that we require to control at whatever cost. Cost is not a major factor there. Safety has to remain intact, and that is very much important. And if we can do that, we can help ourselves, we can help projects, we can help operations for long terms, because though initial time for that process can be 30 years, but it can prolong by retrofitting measures. So we have to be very considerate about this. Whatever work we do on plants, we have to keep in mind that fire is always a danger. Of course, rain is not that important. We can control rains, we can control floods, but fire, which leads to fatalities, which leads to shutdown of whole system, and people have to be rescued from there, because it's question of life and death. So we have to apply our minds, our safety issues to those areas very seriously. We have to be very sure, very confident of that. And because it is processing plant, there are involvements of explosions. It may be due to fire, or it may be due to chemical reactions, or it may be due to whatever reason. You can say pressures are too high in that case because of formation of evaporation, formation of gases in the environment, and this can lead to fire, and this can also lead to blast. Blast, you know what is blast? It's explosion. Of course, it's instantly, it's not for hours. It can take just, you can say 20 seconds, 10 seconds, 15 seconds, but that damage is intensive. Damage that it can give to structure, damage that can do people working there, damage can do something else. That's very, very complicated. And just give me one. I have to go up and come down. Meanwhile, I think you can very well understand. It's sometimes problematic. Just give me a few minutes, please. Sorry, dear, little minutes I took. So we have to move to blast from fire, because blast is a result of fire. It is connected to that one, and blast means explosion, blast means fire, and blast means loss of human resources. Of course, building can also be destructed if there's blast. Blast sometimes can also be, if some flight goes on at very low level, you feel a kind of very high volume of voice. Of course, that is not blast exactly, but likewise, if it's a bomb like situation, explosion like situation, that can be due to gas cylinders, that can be due to whatever other reason, evaporation, you can say formation of chemicals, formation of gases, you can say kind of formation of clouds on your plant, gaseous clouds, concentration of those, and that can lead to explosion, and that blast is very dangerous. It may be instantaneous, it will not go for hours or minutes, but that energy released by that is very explosive, very jeopardizing whole situation. It can cause fire to plant whole as a whole, and maybe fire fighting system. Of course, if it's automatic, it may work, but not necessary, and they have to face losses. For that purpose, generally within 600 meters or little more, 200 meters, not 600 meters, within 200 meters, 0.2 kilometers of that area which is called process area, where main process work, main processes of chemical plant work, oil plant work, that area, if that structure lies within that, it may be compressor buildings, it may be other buildings, it may be wash buildings, whatever building exists there, these all shall be subject to impact of blast in about 200 meters. If you keep center of that process area and draw a circle of 200 meters minimum, maybe maximum more, that area comes under blast stage, and we can say blast resistant is required there. And if you go up to 600 or more than 600, say 610, 15 meters from process area, that portion of 200 and 600 meter in between, that shall be called blast resilience area, in which there may be chances of some effects of blast. And if you go further in that process plant, in that plant, that area shall be normal one, where resistance or resilience of blast would end, and it shall be normal one. So particularly you can say first area is 200 meters and second one is 600 something 10 meters. Inspection is more important in this area of blast, where we have to consider blast related to concrete structures, concrete walling, roof, and blast related to doors and windows in that building, and also substation buildings there, electrical buildings there. There may be, you can say, that type of roads as well. There should be arrangements for immediate requirements, meeting immediate requirements, and that is gases. Particularly, you can say firefighting system is already there. That should be very efficient to work, and if it's better if it works on its own. So I know information about automatism on that. It can be on its own, that's really better, just like smoke detection system in buildings and taking care by sprinklers. Same way we can say, if we have inner gen gas, or FM200, or whatever else modern technique we have. At least in critical buildings, that can be used, because that gas FM200 or inner gen are very efficient in seconds, provided your fire is in sealed area. It can suppress fire, it can extinguish fire within couple of seconds. That's what we have to see. What is the status of that? What is availability of that? How cylinders are stored? And that is what audit requires. Are steel doors which are meant for this work safe or damaged, or requires maintenance, or blast resistant walls are fine, or they also require some retrofitting? Roofs are okay, because in blast, walls and roof of one side work together on blast side, and on non-blast side, that's different one. We have to consider like that roof slab and vertical members should work together. It's not that we can consider only wall, because if wall is affected, slab shall of course be affected. And it's important to consider this. There's a big research on that, considerable research, so much information, so much literature is available, which is of engineering importance, not of safety. But prevalence of that, you can say, availability of such walls, strong working of those walls are required. Walls, and you can say panels or slabs, or it may also relate to steel buildings, that it should work similarly within that 200 meter zone, and accordingly in zone between 200 meter and 610 meters. There's some effect of that, but not that much. So we can provide a design between normal and blast in that area, and then we can provide normal designs in areas which are covered off 610 meters. We have to take care of equipments, that equipments are safe, like gases are safe, and we have to take care of all these cylinders, that they don't blast themselves. Means it's just a brief I am giving you. I am not giving explanatory talks, but generally we receive reports from many parts of world that there is an explosion. This was there in this country, it was there in that country, and that is not a normal. Sometimes news we get, and it is problem all over world. It's not that only in our country it's the problem, it's problem all over world. So that audit must also consider this viewpoint. Then adequate dikes installed around storage of flammable materials. Yes, dikes. Protection must be given to every flammable material when it is on plan, it is on project, and that must be considered by safety audit. It's not very difficult, it's only requirement, and we have to keep flammable material isolated from other materials. There can be many flammable materials, you know all well. Then we go to adequate ventilation installed in building containing flammable material. So material is still same, it's flammable, it is gas, it can be, you can say, other materials of buildings which can catch fire, and we have to protect their storage, respective storage, so that if something happens there, fire is broken out, it should not continue. There should be ventilation, there should be, you can say, some other arrangement like dikes, as I said, dikes and ventilation should be provided. And if we can have some other means of extinguishing, we can also recommend or write that this provision also required. Then we can say then uninterrupted power supply system, and we call it UPS. And is that installed or it's not installed? And if it's not installed, why it's not installed? Has there been no problem of power in that area? Generally, there is no problems on plants areas from power viewpoint. I think non-stop supply is made available, but when there is a problem of fire, we cannot keep lights on, we cannot keep electric on except for running those you can say suppressing machines, suppressing equipment that can suppress fire. For those purpose we need some supply, emergency supply. That is what we have to provide for, we have to audit for. It must be done. If that is not for whole time, it's only that emergency requirement, because so many shutdowns are there, would be there, close downs would be there. Then there's another point, and that is services. There may be, cryogenic services required on plants. These moving pipes, of course, and these services which are at minus temperature, maybe in supplies if not in plants, these must be taken care of because of minus temperatures. These may freeze and may cause problems for delivery. These are cryogenic services, so we can provide one more valve in that double valve. By chance, if some freezes, others should work. Valve may freeze. I am not talking of heat tracing here, because that is in pipe. When this gas itself freezes, gas means liquid gas, liquid at minus temperature, there we provide heat tracing to whole system. Here it is valve issue, so valve should function, it should not stop its functioning. Then we can say ready and safe access. Ready and safe access, particularly during an emergency, to valves, instruments, switchgear and equipment. Access is very important to every part that is to be used for operation of fire suppression, firefighting. There should be no obstruction for firefighting professionals, firefighting soldiers to enter in that area. That access should be available and it should be safe without causing any accident. Particularly during an emergency time, that's what we are discussing. And it can be to valves, they should be accessible to valve. These firefighters should be accessible to all instruments. These should be to switch gears, because switch gears are protective arrangements and equipment. If there is some deficiency, it has to be noted, though chances are very rare on plants, but even then audit is audit. We have to take care of that. Then we can say if there is hazardous area wherever, and we have to provide ladders and stairways, and if these ladders and stairways are located much away from potentially hazardous areas, then you can say it shall be very difficult or inconvenient or time consuming for everybody to use them of long distance. So it should not be these facilities, these ladders and stairways should not be located farther. Within limits is okay, so that time is not wasted. take care of time. Time is very important in such situations, and that time should not be wasted. We don't allow wastage of time. Walking or running to distance doesn't mean anything. So we have to keep them near to hazardous areas. So ladders and stairways located away from potentially hazardous areas should be avoided. Escape routes are also very important for rescue operation. Emergency escape routes must be identified, and that is very important point, and it should be known to everyone all time. There is no way everybody should know what is escape. It should be clear. It should be clearly signed in, signaled in, you can say boarded in. You should provide indications. Emergency lights, it should be installed automatically. They should work, or there should be some control from one point, and somebody should be there on duty to operate that if this is not emergency control, or due to some reason if that emergency control also doesn't work automatically. Adequate fire and gas detection system installed. Yes, that's what we said. Adequate fire and gas detection system installed. This generally applies to indoors buildings. You can say the smoke detector system, that's called smoke detection. If there is smoke, means there must be some fire. So it's generally installed in every building for purpose of loss prevention. Then also somewhere we provide sprinkler system also. We can say gas detection system, fire and gas detection system installation provided functions, means because maybe there is no fire for a couple of years, this may not function. Nobody knows, oh, there is no fire, but generally it doesn't happen. It functions when I experience even some smoke from some kitchen and alarm was on. It alerted. So we can say adequate fire and gas detection system must be installed, and there should be drills also to make sure that these systems work. We have to conduct drills, not every day, once in 6 months, once in 3 months, or whenever we think. It's better because people might have forgotten it. So they should be given, it's a kind of training, you can say. It's a kind of let people know that it's there, or there may be some new arrivals who may not know that. So adequate fire and gas detection system installed, and it should work properly, and it should be inspected by audit team, and that's the important point. Adequate fire and water system installed. That's I already said, ring main unit, but in every place there cannot be ring main unit. In a complex it can be, but if it's an individual building, it's a big building, it has adequate landscape area around it or within this, then we can say okay, we can install ring main unit or firefighting system in this building. Adequate fire water system we can install. That's where we can say it shall be better for everybody. In case of emergency, water can be tapped from whatever hydrant of this. There will be hydrants at different locations, at corners or somewhere else depending on distance, and we can say that those hydrants, fire hydrants, can be used for tapping out pressurized water, which can directly be used onto fire suppression locations. And fire water system must be installed, adequate fire water system, that's what I say. Now, battery limit block valves installed. What is battery limit? Battery doesn't mean battery of chemicals, it means a limitation of our project. A limitation up to which we can say we can work out, and we can provide valves there, we install them in battery limit. It's very important point I'm talking of, and we can even think of it further. What is battery limit? It's not very difficult. Let me just find out if I can explain more on this. Battery limits. Says that a battery limit is a defined boundary between two areas of responsibility, which may be physical, that is a flange on a pipe, or represented by map, coordinate, or some other means, for example, a point in time. Battery limits in a disturbed project are described. Okay, so it says battery limit is a defined boundary between two areas of responsibility. I want to show you if I can find some explanation. It's better. Battery limit, parameter of a specific manufacturing process area, parameter of a specific manufacturing process area. It's often defined by rows around perimeter. This area includes process equipment and may include in process tankage. So there is no specific definition is given, just a line definition is given. And there's no meaning in taking out print of that to show you, because you have to be professional. I wanted professional explanation of that. Battery limits definition. Law Insider, it says it is battery limits means only process sections, grain cooking, enzymatic hydrolysis and mash cooling. It's not, it's something else. Sorry, whatever I do, I try to find, but you can say two responsible areas can be bifurcated. That's what is battery limit, to be very frank. And we can say now guards installed around moving parts of equipment. Equipment, it can be tool, it can be big equipment, or it can be whatsoever. We can say guards, you know what's guard? Installed around moving parts of equipment. Whatever equipment we have, small equipment, major equipment, minor equipment are very important for everyone on projects, on working, and we have to care about them. There can be guards, or you may call guides. Generally on tools we call them guides or guards. You can also call guards. Means there is revolving work. moving work, and people should not touch them, and guards can protect them. Guards installed around moving parts of equipment. That is very important point. It should be. It can protect persons from equipment. HSC showers and eye wash. Safety showers and safety eye wash. Stations installed and supplied with cool portable water. So here is audit of guards, that was one requirement, and also protection of eyes, and also showers we have that in emergency these can be used. You can say bathing, eye wash, these stations are installed, and potable water, cool potable water is supplied to them for purpose of sometimes eye cleaning. There is some problem in eyes, some particles enters eyes due to whatever reason, or we have to wash, we have to take some bath in an emergency. So these should be audited. Maybe points are available, but these points are not functional due to whatever reason. Why not functional? Similarly,